right? So before we go ahead, so hope you saw the previous video, which is where I have given how to set up the Truffle blockchain in the Windows. So please go through that so that you will get to know how to what are the packages how to be installed and how to set up that in the Visual Studio. So then only we can go ahead and making the rating the smart contracts and deploying them in the local blockchain. Okay, now let's start. Okay, now we will see how to write smart contracts and deploy them in a local chain. Right. So now let us see this. So as far as before we start writing the smart contracts and deploy them in a local chain. So I hope in the previous video, so we have seen that. So how to set up the truffle suit in the this particular visual code. So that video is already available in the YouTube of my channel. You can go ahead with that. So now let us go ahead. So first, as I mentioned in the previous video, as soon as you say that truffle init, so we have to make sure that these three folders has to be created: contracts, migrations, and test. So followed by one JS file, it is must. So once after all these are ready, now we can actually step into the creation of smart contracts. So how to create a smart contracts? However, we have a folder here. It is named as contracts. So that is where you'll have to write the smart contracts. So I'll just right click on it and go for new file. Okay, just right click on it, go for new file. So what is the name of the file? So a simple one will let us take up, which is a hello world, right? So basically any programming language we start with this, right? So hello world, and as we'll be writing a Solidity program, so it is a SOL is the extension, right? I'll say hello world.sol. So here I'll write, so first before so this is where we'll be writing the Solidity code. So before we write it, so you'll have to define the pragma. So pragma, so Solidity, pragma Solidity, so the where will be, yeah, Solidity, not Solidity. That's a Solidity, and we'll have to mention the version. See, one thing, where can you find out the version? The sense, so in this truffle config file, so if you click on truffle config file and if you come down, so in this particular file itself, this where you can see the yeah, version of the Solidity in your system. Yeah, this is what 0.8.20, right? 0.8.20. So this you here you can set, okay, here you can set 0.8.20 colon, right? That's how you can set the version of your Solidity, followed by you'll be writing a contract. You'll be writing what? Contract. So the name, so let me keep the same name, which is a hello world. Hello world, right? So hello world. So that is what a simple smart contract I'm just showing. I'm going to just display the public. I'll be just displaying the what hello world. So let me name the variable as a greet. So I'll just say that what I exactly I want to display hello world. I just wanted to display hello world. That's it, simple. As simple as, so I just wanted to display the text, which is hello world, right? So, but yeah. So one thing is for sure, we need to fix the license as well, which is the SPDX license. So you see, even if you don't want to, or if you want to check that, so right now you observe this. This is what a simple Solidity program, right? So once after this is done, you can get to know that license here itself by running the truffle compile. When you try to compile without the when you try to compile, what I'm using just a truffle space compile, right? When you use this truffle space compile, it will compile the Solidity code, right? So when you do this, you can observe it will throw an error. So it will throw an error which is related to the license. So yeah, can you observe this? So this is what the error which I'm talking about. SPDX license identifier, it's not provided in the source file. You have to provide, right? SPDX license provided, you have to provide, you have to mention. If you do, even if you know, if you don't have any respect license also you have to mention as unlicensed, right? You have to mention this SPDX license identifier unlicensed when you don't have any license for open source, non-open source course. When you are using open source things, so it is must and should you must mention that. So in the comment section, so you have to say that SPDX license identifier, so which is unlicensed. Basically, default will be using as MIT. Okay, will be default using MIT license, right? If you don't have also, you as the error only says that you have to use it as unlicensed. So this is a simple scenario. Then I just compiled. Okay, so yeah, fine. See what is happening right here in the sense. So yeah, this is the error. Yes, hello world. After that, hello world. Yeah, let me save this. And when I compile that, so yeah, exactly. So you can observe. So I compiled it this particular file. So and I could able to get the compilation success. So compiling this particular file, which is hello world.sol, and which is saved the artifacts. Let me talk about this artifacts. I'll tell you. So uncompiled successfully using this particular Solidity compiler. Okay, and compilation is success. My dear, you observe this as soon as the compilation is success. Okay, as soon as the compilation is success, here you can observe that earlier, as I mentioned, there were only 3 folders, which is contracts, migrations, and test, where inside the contracts only you created the hello world.solidity, right? Is it not? Now with these folders, you got one more folder, which is the build folder. So when you open this build folder, there would be the same named file with the JSON folder. This is so important. In the previous videos, we have seen that. So when we spoke only about the Solidity program, so this is where, as I mentioned, this JSON will be having 2 parts. One is the ABI part. Okay, till here it is the ABI part, and this is what the bytecode with the metadata. This bytecode is so important when you'll be pushing the transactions, right? So bytecode with the metadata. So this is what you say that as soon as you compile any Solidity program, a JSON file will be created under the build folder, and that JSON file will be having 2 pieces, or you can say the 2 parts. So one part is the ABI part, the other is metadata, which is with the bytecode. See, basically, when you run the similar kind of Solidity program, which is in a smart contract in your Remix, so there also JSON file will be created, but there will be 2 different JSON files. One would be for the ABI, one more would be for metadata, and sometimes it maybe are the same, right? So now you can observe hello world is the Solidity what we have written. For that, as soon as we got that compilation success, so we could observe that a JSON file is created. So after the compilation is success, right? This is a so simple, Solidity program, Solidity code, which is written for hello world. See, one thing, one more difference. Let me highlight here when you compare with the Remix. So, per suppose here we have only one Solidity. Let me create one more Solidity file. So I can say that simple, just to increase and decrease those counter values. I'll say that counter.sol, right? SOL for Solidity. So here, as usual, these lines are compulsory. So I'll just copy paste, right? So then let me define the contract. So while defining the contract, so let me define the contract name as counter. Okay. Name itself mention that counter. So I'll be just reading some value. That value, with that value, I'll be just having 2 functions which can increase and decrease. It just means of counter values, right? Where I'll be increasing and decreasing values. So for defining one parameter or one variable, so I'll just say that I'll make use of integer, which is uint, unsigned integer. So I'll make that variable as a public and space a. I'll just say that a is a variable which I'll be reading. Then I'll also be I will be I'll be increasing and decreasing the values of e. So for reading that value, I'll just function. Yeah, I'll be using the get method, not greet, get method I'll be using for reading that. So in the public, public view, so returns what value? It is as usual integer value. So I'll be returning that. I'll just, let me follow the indentation. Return a. So here a is the value which is returned from this get method. Then let me create one more function for increasing. I'll just incr. Okay. Okay, our simple inc is okay. Okay, so I'll just say increment. It is only for incrementing, and let me make that also as a public. So here I'll say the a plus, it is plus is equal to 1. Making sense? So I'm just increasing the value of a as 1. So this is when in case of increment method. So similarly, I'll just go with one more. Okay, I'll just go with one more function. So for decrementing function, decrement. So okay, and let me make that also as a public, right? So I'll just make sure that a minus is equal to 1. I'm just increasing and decreasing. That's only that is where I'm just coding. This is a simple smart contract for counter values for incrementing and decrementing. Yeah, this is where I just wanted to make it one major factor here is that. So when you will be using, okay, when you'll be using remix, right? So as we have two, you can observe right here, we have two solidity smart contracts, solidity programs, counter and the hello world. When you will be having such kind of two different, okay, two different solidity programs, so when you'll be using so you'll have to compile them separately, okay, hello world separately. But here what happens in the sense, so let me clear it. So here what happens in the sense, even though there are two solidity programs, so if you just compile only once is enough. I'll just say that truffle compile. Even if for your information, let me delete this JSON. No worries. Okay. So don't think that it's already created. No, nothing like that. So if I compile that, what are the two different solidity programs which we are given? What are them? Counter.sol and hello.sol based on this adder itself. So they both of them have been compiled successfully. So only we could able to say the two different JSON files, right? Is that making sense, guys? So we have we have two different solidity programs, which is counter and hello world. These two smart contracts have been these two smart contracts have been compiled so successfully. So only two JSON files have been created. If at all, if you would have used remix, so you'll have to compile each separately. So you observe, so you think you are creating a very huge project which have a hundreds of such kind of small pieces, small snippets of solidity, small codes. So you'll have to compile each of them separately. So right, whereas here what is happening, you can able to run both of them in a single truffle compile command, right? That's one thing. And one more thing let me highlight here is that this, with respect to the version, some of the cases where if your system is not compatible with the current version, so where you may get an error as well. So as I already mentioned that from where to get the version, from this truffle config file, so where you can see the current version of this, it is 8.20, right? So what I'm trying to convey in the sense, in some cases, okay, some cases this version may be different, this version may be different. So in such case, what do you have to do? So let me show you that. First, suppose if the version is different, there is a possibility of giving the range also, my dear. You can also provide the range here. Say, for example, greater than or equal to 0.0, 5.02. It is something like greater than equal to 0.5.0, less than 0.9.0. You can also make out like this. Okay, so now again compile. You can observe, you compile. So when you compile it, say, can you observe this? So it is compiled successfully, no worries, right? Because your version is it not in between 0.8.20, it is in between this range, so you could able to make out fine. So that's what I'm trying to convey in the sense, the version you can directly use this version directly right here. Otherwise, okay, otherwise you can also mention the range also like this. Okay, both are on the same. So hope you are catching up. So likewise, so we are done with the successful compilation of the two different smart contracts, solidity programs, whatever we have written. Okay, we have written these two smart solidity programs for two different smart contracts, which is one is counter and the one more is hello world, which has its own purpose, right? Hello world is just to display the string which is hello world, and counter is to increment and decrement the variable value whatever you provide. And also one more difference I already mentioned. So you'll be in case of truffle, you can compile n number of solidity programs altogether, whereas in case of remix, if you'll have to compile each separately, right? So what we did, so we created we created the we created the what Solidity code, right? And we compile. How do you compile it? So you just made use of truffle compile. As I mentioned, you can compile all those Solidity programs together just by using truffle compile. As soon as you did that, I hope you observed that build folder has come separately and with the JSON folders for each, right? So now we are done with compiling the Solidity any kind of Solidity programs successfully. We are done with it. Now let us go for deployment. Hope you are getting, guys. So let us go for the step of deployment. When you say the deployment in a sense, where exactly you want to deploy? That is the very major point, where very major point you're supposed to know that. It's as same as you will have to tell your system, tell your truffle where you want to deploy these smart contracts. Okay, so in your truffle config also. Okay, as I mentioned, inside this truffle config, where exactly you have to deploy. See, when I say the where you want to deployment, where you want to deploy. So whether you want to deploy in the local chain or whether you want to deploy in the public chain like Ethereum or anything. Okay, so you can deploy whether you want to deploy in the local chain or public chain. As we have considered for the today's topic is only for local chain. So let us see where let us try to deploy this in the local chain only. Okay, let us deploy these two smart contracts in the local chain. When I say that local chain, so which exactly I'll be using, in the sense I'll be using a Ganache. As simple as we'll be using Ganache. So basically, what is this Ganache? In the sense, you can Ganache or Ganache, whatever you call it as. So if you type here, so Ganesh truffle suit, so this is where you can get the Ganesh as well. So you can observe this. You can get the Ganesh from this official website, which is okay. You can get it from this trufflesuit.com Ganesh. So basically, this Ganesh is the one which you can call it as a simulator, guys. So it is a local simulator which can actually simulates the blockchain. If you ask me, is it the real blockchain? Never. It's not the real blockchain. It is simulation, right? It is where you'll be simulating the blockchain in your local machine. It is not the actual blockchain. It majorly will be using this Ganesh for whenever we don't want to use the real blockchain for our experimentations, because it's so costly, and also it is not that so easy. It is dangerous in case of distributed blockchains and distributed systems. So in that case, what is the solution? Let us make use of this Ganesh, right? Let us make use of this Ganesh. So let us test whatever the smart contracts we have written. So let us test them. Let us try deploying them in the local Ganesh. If it is working fine, okay. If it is working fine, then you can think of pushing them on the blockchain or a public chain, which is an Ethereum or any other, right? So in that perspective, so will be in our presentation also today, we'll be seeing how exactly our Solidity smart contracts can be pushed onto the it can create the local blockchain in the Ganesh, right? So this is, as I mentioned, this is the official website, so you can download this. So right, so just click on this download for Windows. Definitely I'm using for Windows itself, right? So I'll just click on this Windows. So even if you want complete snippets, you will get it here. So how it will be there, right? So I'm just downloading the Ganesh for my local mission. Okay, I hope it's clear. So we will be using the Ganesh for creating the local blockchain in my own system. So if you ask me, is it a public? Can anybody else can access? No, it is only private to me. It is only on my local mission. So when do we use it? So whenever I do want to perform any kind of experimentations, so by changing the Solidity codes with respect to different smart contracts, in such case, instead of you directly run, throw them on the public chain, and so first let me test them on the local Ganesh, local blockchain. If it's working fine, then let me think of pushing onto the actual chain. That's what the same, right? So that's what the importance of Ganesh. So which I've just done with downloading, I think. Yeah. Yes, Ganesh is ready. So let me install it. And installation also is so simple that, like however other softwares we did in the previous. So just double click and just keep going. It will be installed. Yeah, it is taking a couple of minutes. Right. So this right once after Ganesh is installed. Check it out. So just type Ganesh here. Yes, it's installed. So open that. When you open that, so you okay, this is the home page. So if you want to create your own new workspace, you can go ahead and create in this new workspace by importing the truffle this one I told you, right? Truffle config.js. So if you don't want to so if you don't want to use that new workspace, you can directly just click on quick start. If you just click on quick start, it's enough. So where it will create, it will open you the local blockchain Ethereum, right? So I'm repeating this. This is the local blockchain. This is not the public blockchain. It is not being hosted anywhere. It is hosted on your own local machine, right? So I should show you that. Fine. So you can page of the Ganesh, so where you can observe the different IDs and Ethereum, 100 Ethereums for every address, right? Don't think that these are the real values. So these are just a dummy values. Okay. I don't think that you can buy something with this Ethereums, Bitcoins. No, nothing like that. You cannot. Okay. So as of now, there are no transactions in the every address. You can observe these are all the addresses of the blockchain. These are all the availability of a balance of Ethereums, Bitcoins, and these are the transactions which are issued as per now, so which are zero because nothing has been, purchased or nothing been utilized. Next, you can observe here there's a blocks where you can observe zero number of blocks. As of now, no blocks have been created. Transactions is null. Like that, you can observe there are no more contacts. So because we just launched this Ganesh right now, right? So where nothing is being recorded or nothing is being inserted as a block or nothing is being issued as a transaction. Now let us do that. Okay, so now quickly let us go back. So as we are right, we have done with creating two smart contracts. Okay, one is for counter and one more is hello world. Now, so how do I push them? How do I deploy them onto the Ganesh? As I mentioned, Ganesh is a local blockchain simulator. So now whatever the smart contracts which have been written in this truffle, which I have to deploy onto the Ganesh. So you'll have to speak with the Ganesh. So it's something like truffle it has to speak with the Ganesh. So how that communication I can build in the sense it is the same as within this truffle config file. Okay. However, I told you that there is a a version which you can find out from here. Similarly, so you can make the truffle communication with the local blockchain like Ganesh, or it can be the public blockchain by using either it can be Infura or Alchemy. So whenever you would like to have with the public blockchain, you'll have to use these set of lines, which is Goerli. Okay, so these set of lines. But now as I'm going to talk with the local blockchain, so I'll have to use these lines. So let me uncomment this, which are already commented. So let me remove that comments. Okay, as we know that, as you all know that, so as we are, I'm trying to push this onto the local blockchain. So the IP address would be same 127.0.0.1. Even if you want to have a clarity on this, where can you get it? So just go to your local chain, which is Ganesh. This is where I hope you can observe this, which is RPC server. What is the IP address of it? Which is 127.0.0.1 because it is a local, and followed by a port number which is so important, which is 7545. 7545 is the port number where 127.0.0.1 is the IP address. Now what do you have to do? 127.0.0.1 is already been recorded as a host IP address right here, whereas the port number is recorded as 8545, which you have to change as 7545 because this 7545 is the port number for the local Ganesh, which is in the UI based. If you want to run in the C, as I mentioned at the beginning itself, you can run the same truffle in the CLI also, which is command line interface also. If at all if you will be using CLI based, in such case to talk with the Ganesh at that time we'll be using 8545, which will be a default thing. But as right now we are using the UI based Ganesh, so you'll have to use the same port number, which is 7545. It is common for everybody. Okay, so as I'm not going to talk with any other system, it is in the same system. I hope you are getting the point. Truffle also, I mean, it is there in my local mission. Even Ganesh, this Ganesh is also there in my system. system, my local machine. So as of now, you can observe right here, the balance Ethereum is 0 Ethereum, and there is address. This is the address for the first try, and there is no transactions have been initiated, and the blocks is also null. Now we are going to start pushing these two smart contracts onto our Ganesh, right? So now let us do that. For doing that, so we need a migrations. However, there is a build and contracts. This is where we have written the solidity. Now we need this migrations folder. We'll jump into this migrations folder where we need to write a JS files. I repeat, we need to write a JS files. So how do we do that? So as usual, I'll just go right click on it, go for new file. I'll just say that, so for the counter, I'll just say that counter.js, right? I'll just say that counter.js. So this is where I'll have to write. So I'll initialize one variable as a counter itself. It is just a variable. It is not the Solidity program name. You can say it as anything, okay? And I'll be using artifacts. As I mentioned at the time of compilation itself, artifact, this is so important. Where after compilation, where is your build file? It is there in this a location which is given by the artifacts. So I'll have to use artifacts dot require. So where is my source file? Require. So where is my source file is so important. So where is the source file in the sense? So it is there in the dot slash. This is source file, right? For this counter, this is the source file, which is counter.sol. Counter.sol. I repeat, this counter.sol is the file name of my this Solidity program of this particular smart contract. Whereas, so which is available in the artifact. So I'll be using artifacts.require, which is to your build folder. Okay, and this is a variable. I repeat, this is just a variable. You can say it as anything, right? So that's how I initialized one variable which is pointing to the counter.sol. Now let me deploy that by using module.exports is equal to, let me write a function. So in that, let me again use one variable which is named as deployer. So this is where I'll be using deployer. Deploy is a method. Deployer is a variable. Deploy is a method. So what I have to deploy? This variable. Whatever the variable I have used, this variable I have to deploy. So I'm done with. So writing a JS file in the migration file, you can also call it as. So this is what. So where I am pointing to the artifacts.require. I'm pointing to where. So counter.sol. So this variable I have to deploy. So for which I am writing a function separately. Function deployer. So deploy of this variable. So I'm done with writing a what JS file, which is a migration file for your counter. And similarly, I have to write for hello world also. So hello world. So let me define that hello world dot js. Fine. So the same thing. So whatever I have here, the same content, let me copy paste. Whereas instead of this counter, I'll say that hello world. Making sense? Hello world. Whereas same keyword hello world, I'll have to use here. Fine. So and this one also same hello world dot solve. So I'm done with writing the migration file for both counter and hello world. So two migrations files have been created for two different smart contracts. Okay, one more very important point I would like to stress upon here is that you see, you can write the Solidity files like however you want. But when it comes to the migrations file, writing the migrations file like this is a bad habit. Why exactly, why I'm saying it as a bad habit in a sense, at the time of deployment, so it is very, very important for you to mention which smart contract has to be deployed in what order. What I'm talking about, see here, this whatever the two Solidity files which have created, which is counter and hello world, so which are not connected with each other. Making sense? So counter and hello world, these two are two independent Solidity codes. Per suppose if you are building a so huge project, in that if at all, if you have 10 Solidity programs, where 10 out among which, if at all, if they are depending on each other, then at the time of deployment you have to deploy the independent file first. That's what example saying that if there are 5 files, second file is depending on the first file, third file is depending on the second file, the fourth file is depending on the third file, like if it is like that, and if you don't mention the order of deployment in the migrations folder, what is going to happen in the sense, if you don't mention the order of the file, so files whatever you create, it will be placed based on the alphabetical order. I hope you might have observed already. See, counter, see, so it will first, it will come first, again hello, h will come next. See example, even if I create one more file which is abc dot js, so it will come and sit at the beginning. If I create one more file which is zoom.js, it will go and sit at the last, because they are ordered in the alphabetical order. But per suppose if ABC is depending on the counter, but what is happening right now, ABC is going to be deployed first, then counter will be deployed. So what is going to happen, as ABC, as counter is ABC must be deployed only after counter, but based on this order, it is going to go, it is become trash. So what you have to do in the sense, let me delete this dummy right now. So what you have to do, how to solve that, so do provide the order of deployment. How to provide, to provide in the file names itself. So here, if I want the counter should be deployed in the second, and I want hello should be deployed first in the sense, then I have to use 1_ for the hello. Making sense? So here, even though in your smart contracts, hello is in the second place, counter in the first place, but here if I want the hello word to be deployed first and counter to be deployed later, it is me who have to define the order. If you don't define the order, what is going to happen in the sense, automatically list of files will be added in the alphabetical order, and they will be deployed in that order itself. They will try to deploy in that order itself, which is going to become problem, because whenever there is a dependency of one smart contract to the other. Okay, so that's what mentioning about the order is so important. So now we are done with creation of migrations files and the migrations files and setting the order. Now let us go for migration. So to do that, as usual, so truffle. So let me clear this first so that it will be visible, clearly visible. So I'll say truffle space migrate. So just truffle space migrate. So if at all, if you have mentioned the IP address and the port number of your Ganesh, which is 127.0.0.1 and port number is 7545, clearly if you have mentioned in the this config file, so this whatever the two smart contracts you have written, so it will be deployed successfully. Okay, now it is hitting a error. Okay, let's see that error. Hit an invalid opcode deploying, try verifying your constructor parameters. See, it is throwing you error saying that in the hello-world.js, it while at that time, so hello world hit an opcode deployment verifying. Okay, same error it is showing. Okay, let me see the code where hello world artifacts dot require, correct? Hello world dot solve, correct? Module dot exploration, correct? Deploy, it is correct. Even then it is throwing you error. What might be the reason? See, let me show you one case. Let whatever the version we have, let me reduce this version. Let me make it as instead of 8.20, let me make it as 7.3. Okay, let me make it as 7.3. And in the Solidity code as well. Anyhow, here I had given this. Okay, so this I mentioned this where at the time of generating this Solidity program. So giving this in and between versions instead of the exact version. So now let me try out. Fantastic. Now you can observe. So we got both of the smart contracts have been deployed. So before that, what did I do this for clearing this error? What did I do? Just a very simple thing. So the default version was 0.8.20. So what I did now, in the sense, I just reduced the version, because there is a concern, because where I am running my Ganesh, I'm running in my local machine browser. Whereas if it is not compatible with the current version of your truffle, definitely it is not going to work. So what I did, instead of 0.8.20, I just made it as 0.7.3. So randomly I just reduced it. So for to work with this any version, what was given instead of 8.20, so I just made I just gave it as a from and to. It is in between, you can observe it is greater than or equal to 0.50 to less than 9.0. Same thing I just made it as. So I just changed the version and it quite worked better. So there is no error with respect to the Solidity program, or it can be JS code, right? Now coming to the results. What is the result? You can observe here. You can observe network name is deployment, as we are not specified any network name specifically. So it took the network name as deployment itself. What is the network ID? It is the same network ID, which is 5777. You can observe in the in our results as well. It is a 5777. And gas limit, whatever the gas we had earlier, gas limit, whatever you can see in the, it is the same results you are seeing in this command line interface, and the same results you can observe in this Ganache UI, which is in interface as well, right? So how many transactions have been, how many blocks have been created, how many transactions have been issued, so that you have to check it right now. See, while deploying the hello world, it is generated with the hash, which is very important, hash which is starting with 7811 like that. And where exactly it is pushed, it is pushed at the contract address is what 0 followed by 88A4. So you can observe. So you have to verify this, right? Where exactly it is in the, this is the smart contract address. Sorry, this is the hash address. This is the hash value, and this is the account. Where is the account? This is the account, which is 044317. Is it not the one? 044317. Making sense? It is the same 04437. So in this, the block is being pushed. So only now you can observe this transaction count is being increased to 2 right now. So the transaction count is being increased to 2. Earlier it was 0. I hope you remember that. And also you can observe in the blocks. If you click on the blocks, earlier it was 0. Now we got the 2 more blocks, which is block 1 and block 2. This is what the minor block which will be already available, which is the default block, right? Without having any transactions, this is the default block, which we call as a genesis block, right? In the blockchain terminologies, we call as genesis block. Without any transactions, it will be available already. So it was there. So right now, these are the two blocks which we just pushed. If you want to see, just click on this. Okay, if you just click on this, where it will show you what is the hash ID, which is 781106. Is it not the one? 7811066906. Okay, that's the one. Again, similarly, if you want to see the contact address, which is a source address from where the smart contracts have been initiated, which is 88A4. So you can observe, which is here, which is 88A499, right? So this is the transaction which is issued from the first smart contract, which is hello world. I already, again, let me repeat this. So why hello world is pushed first? Because we gave the order here. We gave the order here, even though when you generated the smart contract, so you gave first counter have been initiated first, then you have initiated the hello world. But even then, order is like this. But first, which is pushed first? It is the hello world, because we gave the order here externally or explicitly. We gave the order as first hello world, next is counter. So hello world is being pushed with the block number 1, with the so and so timestamp, with the so and so transactions, what is the balance which is available, all this, right? So which is what is the total cost, all that you can observe. Next block is what, with respect to the counter smart contract, where it has its own hash value, it has its own contact address, but account ID is same. You can observe account ID is same. When you go to the accounts, so it is in the same account, it is in the same account only, it is also being deployed. So the second smart contract, which is the counter, is also being deployed into the same account, which is 44317, with the different hash and different source address. If you want, you can click on this blocks. You can click on the blocks. Now you can click on this block 2. So where you can observe the from address and the contract address, right? So hope you are getting this particular thing. That's how you can keep deploying any number of you know smart contracts over the blockchain, and especially this is a local blockchain, local chain, where we are simulating by using the Ganesh. So this what if at all there are plenty of smart contracts which are independent. So in such case, even if you don't mention the order, also no issue. But if at all there are dependent smart contracts, then it is must you must specify the order. Then only you can get the actual. Then only you can get the actual deployment because of dependency. Now you can see the transaction. There are two transactions because of the two blocks, right? So two blocks have been created because of the two transactions have been issued. Fine. So if you want, I can also interchange this so that you can see feel the difference in the hash. If you want, you can record this hash and the contract address and change these things, because here we are demonstrating only for two smart contracts, but you may have any number, right? So that's the thing. So whenever you have a difference. Now, so I have to make hello world as 2, yeah, counter as 1, right? No, I have to make counter as 1, yeah, right. Now so I made a counter with the as 1. So hello world is 2. So what is going to happen? Counter will be deployed first, and hello world will be deployed next. So let me migrate it by using a truffle migrate. So now you can observe. So what is deployed first? So in this compilation is success. Now you can observe. So in the same network ID, first what is being deployed? It is a counter. Earlier in the previous case study, I shown you hello world was deployed because we had given the order as 1 for the hello world. Now we gave it as 2. So now we gave counter as 1. So counter has been deployed with the so and so hash ID, so and so contract address. See, similarly here also it will be changed. So earlier you can observe this. So earlier we already had the 2 blocks. Now we got 2 more blocks. So it is not overwriting at any point. This is the one more point, like it is a common to blockchain, right? So any number of times you try to issue the transactions, it will not be overwritten. So a new block is being created. So like this, so total 4 blocks have been created in the same account. So earlier we had the different order. So 2 blocks were created. Now we change the order and 2 more blocks have been created. Now, so the counter has been deployed first, then hello world has been deployed later. Where if you observe, the hash will be different, contact address will be different. It is never be same. So you may be thinking that it is the same smart contract, right? So no, it is not same for the blockchain. It is maybe same for us, right? So it is going to consider it as a new blocks only, and it is creating a new blocks with the new hashes, new from address. From address would be same. New hash and the new contract address. Contract address and the hash would be different. From address would maybe same, right? That's how you'll be showing. So because of the 4 transactions, so you can observe 4 transactions are being created here. Yeah, that's how you can deploy any number of smart contracts from the truffle on the local blockchain, which is Ganesh. So this is only, as I mentioned for a couple of times, it is only the local blockchain. So only it is not, you are not spending any ethers right here. You can observe 0 ethers. You're not spending anything. But definitely when it comes to the real blockchain, which is a public blockchain, you have to spend, you are allowed to pay for it, right? So for which you can go with either, best thing is that you can go with the default Infura itself. So as I mentioned, this is the code. These are the 4 lines which you're allowed to use for local blockchain. Whereas if at all, if you want to go with the public blockchain, which is Ethereum, so in such case, you'll have to use this Goerli, and at that time you have to use this Infura. Okay, you have to use the Infura. If you don't want to use Infura, there is an alternative, is Alchemy. You can use Alchemy or Infura whenever you want to push it onto the public blockchain, but for which you'll have to pay for it. So in such case, you'll be using the MetaMask as well. Fine. That's the end of the concept related to the local blockchain. Thank you.